Hi class. For the second section or second packet or second activity for straw rockets, what we're going to do is we are going to test the nose cone mass. So we're focusing on the mass part of this activity. And as you look at your assignment, the objective of this is to vary the mass of the nose cone to investigate the effect on a rocket's range. So in other words, will a heavier rocket fly farther because the inertia takes it farther, or will it dive and crash first? Will the lighter one fly farther? So you have some vocabulary that you need to finish. Make sure you look at the vocabulary and write the definitions in. Then our first question, our hypothesis. This is using your prior knowledge. What is your best guess? Define a hypothesis. Which rocket do you think will travel farther? Circle your answer. So from the diagram, you can see that there's different nose cones. Everything else should be the same. So different size nose cones. Imagine that these were solid metal or steel or whatever you put in them. So you can look at them and see that they're all different sizes. There are some different shapes, but mainly the different sizes. So make a prediction which one you think would fly farther if they all had the same amount of fuel in them. Circle that one, whatever one it is, and then explain two reasons why you hypothesize or think your choice will travel farther. So please come up with two good explanations and try to avoid the word it and use, say, rocket C or rocket D or rocket A, whatever it is, and explain why, what about that nose cone or weight that you think it'll be different. So go ahead and do that. Then moving on, the next part is to brainstorm. So what style and size of nose cone will you create for your rocket? For a lot of people, they might be creating a new rocket for this packet. Some people will be using the same one. It's kind of different. So put the nose cone that you want to, the shape that you would use and the fins that you have on your rocket. So if there's any changes, you can write it there, but that's okay. So then we're going to choose and if you're working in a group or a partner, this is where you need to talk about it if you're going to make any changes to your rocket before you start the testing. Then we're going to build it. We're using a 10 centimeter straw or rocket, so the rocket will be 10 centimeters long. You can use 2 to 5 congruent fins. I think any more fins and it gets to be too much and too much air resistance. The nose cone from the clay. So this is our variable that we're changing this time. We are going to, first of all, do the 1 gram, similar to what we did in a previous experiment. We're going to add an extra gram, so we're going to go to 2 grams, and then finally 3 grams. So I already have these weighed out. I have the 3 different grams, and you can get a visual here. Let me show you for a quick second. I don't know if I can show you well enough, but these are the 3 sizes. It doesn't look like a lot of difference. A little crooked there. So it doesn't look like a lot of difference, but there are some differences in the sizes. There are some differences. Okay, and 1 gram is not really heavy difference, but it does make a difference when we're talking about a 10 centimeter rocket. So you can try those, and if you are at home or testing them separately with a paper rocket. If you have the access to like a kitchen scale, a digital scale that can measure the different grams, you can use amount of tape or something or different clay to make those size nose cones. So the shape of your nose cone should be the same for all of your testing today. Now, when you launch your rocket 3 times, you need to control the variables. So from this table, it's probably easier to see. The only variable that we're changing is the mass of the nose cone. The shape should even be the same, but the size or the weight will be different. The straw length will be 10 centimeters for all 3. The trajectory or about the angle that we're launching is about 45 degrees from the ground. So keep the trajectory the same for all 3. Plunger force again, so the plunger force of whatever force we're using to launch these rockets needs to be the same for all 3 tests, and we're using 10 with the rocket launchers. So once you test it 3 times, find the mean data, Then you can add another gram of clay or gram to your rocket. So if you had one here, you just need to add another one to make 2 total. And then you can test it. And then the third test, you can add 1 more gram. So you would have 3 grams total on that nose cone, and then test it 3 times. So once you're done testing that, you'll want to graph the data. So we want to communicate our data in a way that is easily recognizable, easy to read for others. So we'll create a data, follow the guidelines. Don't forget to include the label here, and you want to make a scale that will stretch out as far as it can and use as much space as possible. Then answer the question. Using data as evidence, explain the relationship of kinetic energy to mass of your rockets. So using our data, how did the rockets fly compared to mass? What were the differences? What could you tell me about mass and how a rocket will travel? So explain that in, hoping a couple sentences. Avoid the word it. Please use specific words when you're talking about the rockets, whether it's the 1 gram rocket, the 2 gram rocket, or the 3 gram rocket. So talk about it specifically, please. And then final, you have some questions that you need to answer and complete the packet. So good luck with that. If you're absent or doing this from another place, virtual students, you can go ahead and use the data that I provided unless you're doing your own test. All right, thank you.